Hello, I'm Sri from CBTU. Welcome to the Ethical Hacker Training course based on CH certification program by EC Council. Module SQL Injection, Section Mitigation of SQL Injection Attacks. SQL injection is a code injection technique used to attack data-driven applications, in which malicious SQL statements are inserted into an entry field for execution. Code injection is the exploitation of a computer bug that is caused by processing invalid data. Injection is used by an attacker to introduce or inject code into vulnerable computer program and change the course of its execution. Code injection techniques are popular in system hacking or cracking to gain information, privilege escalation, and unauthorized access to a system. Some of the mitigation techniques are parameterized statements, enforcement at the code level, avoid escaping, pattern check, and database permissions. Use parameterized statements instead of embedding user input in the statement. With the most development platforms, parameterized statements that work with the parameters can be used. Sometimes they are called as placeholders or bind variables, instead of embedding user input in the statement. A placeholder can only store a value of a given type and not an arbitrary SQL fragment. Hence, the SQL injection would be simply treated as strange or invalid parameter value. In many cases, SQL statements is fixed and each parameter is a scalar, not a table. The user input is then assigned bound to a parameter. Enforcement at the coding level using object relational mapping (ORM) libraries. This avoids the need to write SQL code. The ORM library in effect will generate parameterized SQL statements from object-oriented code. The best way to prevent SQL injections is to escape characters that have a special meaning in SQL. Any manual of SQL DBMS explains which characters have a special meaning, which allows creating comprehensive blacklist characters that need translation. Every occurrence of a single quote in a parameter must be replaced by two single quotes to form a valid SQL string literal. Routinely passing escaped string to SQL is error prone because it is easy to forget to escape a given string. Creating a transparent layer to secure the input can reduce this error proneness, if not entirely eliminate it. Integer, float, or boolean string parameters can be checked if their value is valid representation for the given type. Strings that must follow some strict pattern, example date, UID, alphanumeric only, etc., they can be checked if they match this pattern. The most important mitigation technique is limiting the permissions on the database login used by the web applications to only what is needed. This may help reduce the effectiveness of any SQL injection attacks that exploit any bugs in the web application. For example, on a Microsoft SQL Server, a database logon could be restricted from selecting some of the system tables, which would limit exploits that try to insert JavaScript into the text columns in the database. Deny select on sysobjects like this. These are some of the hacks with SQL injection. The latest one being British Telecom's TalkTalk server stealing 157,000 customers' data. No solution or no suggestion is 100% perfect. However, continuous effort must be put to prevent SQL attacks to protect digital assets. Generally, exploits occur due to coding errors and inadequate validation checks. Better coding practices, peer verifications, strong database admin procedures can help mitigate attacks. And further to consider, minimize the privileges of database connections, disable verbose error messages, protect the system account (SA), audit source codes for escape single quotes, input validation, reject known bad input, input bound checking, etc. Thanks for watching.